If we want to use the binomial table and the probability of P is greater than 0.5, we have to change the random variable into the equivalent random variable. Why? Because in our table, the probability of success, that is P, is only up to 0.5. So if our probability is 0.51, so we have to change the random variable into the opposite random variable. For example, if we have X is binomially distributed with N and P, so it equivalent to the random variable Y also distribute binomially with N, but the probability here we will use Q. So Q is 1 minus P. So if we want to find probability X equal to small x, so X here is referred to the X random variable. So since P is greater than 0.5, so we have to change the random variable and also the number of success. So if we have a probability X greater equal than X for the Y random variable, the notation will be opposite. So make sure the notation here has a equal notation here, greater equal. So we can change into Y random variable. Okay, if we have X less equal than X, so the notation here will become greater equal. For example, if we have X is binomially distributed with N 15 and P is 0.7, and assume that the question is find probability X greater equal than 5. So so the notation here is greater equal. It's already have equal here. So we change into Y random variable with the same N, but the probability we change into Q. And for the question, we will get probability Y, and the notation has been changed. It's become less equal, and for this value we get from 15 minus 5, we get 10. Okay, another example, X distribute binomially. Okay, we have N 8 and P is 0.55. Okay, let's say the question asks probability X less equal than 3. So we have to change into Y random variable since the probability of P is greater than 0.5. Okay, so the new probability of success, or we can say the probability of failure, is 0.45. Then we write the question as a Y random variable. It becomes Y greater equal than 5. So this value 5 comes from 8 minus 3. Example 8. Let X be a random variable such that X is binomially distributed with 10 trial and P is 0.8 by using binomial table. Find this probability. Since our P is greater than 0.5, so we have to change the probability of success here. So first, if for random variable X, the probability X less equal than 4, so if we change into Y variable, it becomes Y greater equal than 6, because 10 minus 4 is 6. So we'll use this probability. Okay, so we use Y random variable. So we find the answer in binomial table by using P 0.2. So we get the answer is 0.0064. For question B, for X variable, it is probability X less than 4. But we cannot change into Y variable since the notation does not have equal sign. This probability we can write as probability X less equal than 3. For variable Y, we can change the probability become Y greater equal than 7. So we use this probability. Look into the binomial table P 0.2, and we get the answer is 0.0009. Question C. Question C, probability x greater equal than 4. So we change into y variable. So it become y less equal than 6. So to get the answer for probability less than, we must do 1 minus. So we write 1 minus probability y greater equal than 7, because we just want 0 until 6. So 7 to 10 must exclude. So that's why we minus probability y greater equal than 7. So by referring to the new probability 0.2, find the probability in the table, or this value we already get from the question B, and the final answer is 0.9991. For D, the question is probability x greater than 5. So we write into the x greater equal than 6, so that we can change into y variable. So it become probability y less equal than 4. So for the solution, we use probability y less equal than 4. Remember, if the probability is less than, so we have to write 1 minus probability y greater equal than 5, because we must exclude y5 until 10. Then we use probability P0.2 and get the answer in binomial table, minus this probability, so we get the answer is 0.9672. Example 9. Let x be a random variable such that x is binomially distributed n20 and p0.8 by using binomial table. Find this probability. For this example, we will find the probability in between. So how we want to find if the probability of success is greater than 0.5. For x variable, we can separate this probability by x less equal than 14, means that it will include from 0 until 14. But this question, the value of x that's include is 11, 12, 13, and 14. So this probability here is from 0 until 14. So we have to minus from 0 until 10. Then we will get the x 11 until 14. Then we change into y variable. Since p is greater than 0.5, so this probability, the notation is less equal. So we can directly change into y random variable by change the sign. It become greater equal 6. By 20 minus 14, we get 6. And for x less than 10, we get y greater equal than 10. 20 minus 10, we get 10. Then we find the probability using binomial table according to this value of p 0.2, and calculate the answer is 0.1932. We have alternative method here. So this question in x variable, for y variable, we write like this. First, we make probability and the bracket. The notation also same, but the variable is y. To write the number here, we get from 20 minus 11, then we get 9. 20 minus 14, we get 6. And then we exchange the place. So it equal with, if we take y greater equal than 6 minus with y greater equal than 10. For the question B, probability from 15 exclude until 18 include. So before we change into variable y, we have to make sure the notation is in equal. So we have to write into 16 until 18. For x variable means that we can find from probability x less equal than 18 minus with probability x less equal than 15, because we want probability from 16 until 18. For y variable, we change the notation here, and the value of success will become value of failure. 20 minus 18, we get 2. Minus with y greater equal than 5. By referring to the binomial table, we get the probability and calculate the final answer is 0.5604. Example 10. For a random variable x with a binomial distribution, x is binomially distributed with n 10 and p is 0.45. Find a when, so given this probability. Right now we want to find the value of a when it given probability. Okay, how to find this value? Okay, the value of a. So by referring to your binomial table, and we know that in binomial table, if we want to use that binomial table, the notation must be greater equal. So since the notation is already in greater equal, so we can straight away using the binomial table. Now you find in your binomial table, look for this probability under column P 0.45 and N is 10, and you will get the value of R or X, or in this case the value of A is 5, means that the A is 5. For the question B, we have probability X greater than A equal to this probability. So the difference between this question is the notation. Okay, if we look here, the notation is greater, so we cannot use the binomial yet because the notation must change into greater equal. So if we look at this number line, so we have A here but exclude and greater. So that's mean, remember this is a discrete distribution. So if it's exclude, then the next number that's include is A plus 1. That's mean probability X greater equal A plus 1 equal to probability given. So if we look into the binomial table, find this probability, and you will get the value of X is 4. So if we compare, make sure the notation here is same. Then if we compare, A plus 1 equal to 4, then A is 3. For the question C, X less than A. Then we know that to use binomial table, we must have greater equal notation. So we look at this number line, A less than. So A is exclude. If we want the probability, means that we want to get probability less equal than A minus 1. So how to find the probability when the question given is less than? So we know that probability for all value of X is 1. We have to minus the exclude. In this case is A until N. So it becomes 1 minus P probability X greater than A. So we have to minus start from A and greater. Then we make this probability as a subject. So we have to look this probability in the binomial table, and we get the value of A is 7. For the question C, probability X equal to A. The probability is 0.2384. So this is the value of A. In the binomial table, it has X greater equal than A. It means that start from A until N. But we only want A. So we have to minus from A plus 1 until N. Means that we have to exclude probability X greater equal than A plus 1. Then we only get probability of A only. So we write like this, and this operation equal with this probability. To find the probability here, by using try and error, we can get the difference between two probability. Okay, this is a binomial table. Okay, the P is 0.45 and N is 10. So we have to try the difference between two probability. We get the, so this is the column that we must focus. Then we try to get the difference between two probability. So we try these two value. Okay, so that's not the answer. Then next we try, still not the answer, so we try again. We try 3 and 4. Okay, no. 4 and 5. Okay, that's the answer. Means that the probability that we are looking for is x greater equal than 4 minus with x greater equal than 5. So we write x greater equal than 4 minus with x greater equal than 5. So that we can get the answer is 0.2384. So if we compare, we can get the A is 4. This A, so we compare this, we can get A is 4. If we compare A plus 1 equal to 5, we also get A equal to 4. Example 11. In a medical research, a new drug is being tested against a specific disease on human. Clinical tests show that the probability that a patient with the disease is cured by taking the new drug is 0.75. If a patient are treated with the new drug, find the probability that. So this question, this example, we have to identify the keywords. So the keyword here is probability cure is 0.75 and 6 patients. So we can write into binomial notation. X is distributed binomially with 6 trial and P is 0.75. So for the question, exactly 4 of them will be cured. The keyword here is exactly 4 and we want to find the probability that they are cured. So we can use this probability because 0.75 is probability of cure. So we can write the probability as equal to 4. Question 2. At least 1 will be cured. So at least 1 means that the minimum of patient to be cured is 1. The minimum. So it can be 1, 2, 3 until 6. So we write the probability as greater equal than 1. For number 3, not more than 3 of will be cured. So the keyword here is not more than 3 will be cured. So here, not more than 3 means that the maximum number of patients to be cured is 3. So we write as a probability x less equal than 3. The solution, let's say x is the number of patients who are cured after being treated with the new drug. So the notation of binomial. Since the probability of P is greater than 0.5, so what we need to do is we change into the y random variable. Means that 0.25 is the probability that the patient are not cured. So for the question 1, x equal to 4, so we change into y random variable. It becomes probability y equal to 2. Then we get from 6 minus 4 is 2. Means that 2 patients are not cure. So not cure, we use the probability not cure. For this probability, you can use formula or you can use binomial table by taking probability y greater equal than 2 minus with y greater equal than 3. Then you can get this probability in the table and calculate the final answer. Question 2, x greater equal than 1, at least 1 patient are cured. But we have to change into y random variable, become probability y less equal than 5. 6 minus 1 is 5. To find this probability, the notation is less than equal. So we have to do 1 minus probability y greater equal than 6. Get the probability of this in your table and get the final answer. For the question 3, x less equal than 3. So we change into y random variable. It become y greater equal than 3. By 6 minus 3 is 3. We look here, the notation is already in greater equal. So we direct use the binomial. with probability 0.25, and we get the answer is 0.1694.